Okay, so in this video I'm going to be talking about Systemd. Now, to be able to follow along in this course, you're going to need a Systemd system. So I'm using CentOS 7.1, but any Systemd system will be able to follow along with. Okay, so Systemd, like init, is the first process that runs after the init, RAM, FS, and kernel startup. It's the first process that runs. And you can confirm that by going top-p process ID 1. And you can see that it's Systemd. And Systemd will basically go through and it will load up all the services depending on what target you're running. Now, the targets on a Systemd system is a little bit different to run levels, but if we go usr lib systemd system, and if we go ls *.target, you'll see all the different targets that are in here. Now, even though there's lots of targets in here, we don't really use a lot of them. So the main target is the multi-user target. So that's the same as like a command line, like pretty much level 3 in an init-based system. And you can see that we have a graphical target, which is like run level 5 on an init system. We have halt target, which is like the level 0 target. But a better one to use would be power off, because power off will actually power the system off. So you could think of power off as run level 0 to power down the system. And we should have a reboot target up here. We've got reboot, which is the same as run level 6 on an init-based system. But you can see that we also have these symbolic links for run levels that have been created. So if we go ls-l run level, let's do D as well, make it. So you can see that run level 0 links to power off target. Run level 1 links to the rescue target. So that's the same as single user mode on a run level 2, 3, and 4 all link to multi-user. Run level 5 is the graphical target, and run level 6 is the reboot target. Now, this is just for backwards compatibility, I guess, for people that are familiar with an init system. But really what you should be doing is just going, I want multi-user target, I want graphical target, or I want a rescue target, because that is the way that the new Systemd system works. Now, if we look in one of these files, like if we less the graphical target, you can see that it's got information about the target, like graphical interface, it's got documentation, it requires multi-user target, it says that it conflicts with the rescue target, so it's got information in there about the target. So now if we look at the multi-user target, you can see that it requires the basic target. It conflicts with rescue service and rescue target. So it has all this information in there that basically means that the basic target has to load up before the multi-user, and multi-user has to load up before the graphical, and it's like an event-based system, so multiple services can load at the same time rather than it being a sequential one after the other list like the init system. So a Systemd system will boot up a lot faster. So on a Systemd level, Systemd system, you can use a systemctl get-default to find out what target you are. So that's the same as running the run level command in an init-based system. And in fact, if we run level, it will say that we're level 5. Now that's only because the Systemd people have sort of put a little bit of backwards compatibility in. but we're not really on run level 5. We're on the graphical target because Systemd uses targets. Now, if we wanted to change the default target that boots up, what we can do is we can use Systemctl set-default, and we could go say multi-user target, and we'll have to use sudo. And you can see that it creates a new symbolic link for default target to be the multi-user instead of graphical. So now if we run get default, you can see that we're now multi-user target. So so now we're back to being the graphical target again. Now, for starting and stopping services is much the same as on a init-based system, except everything is done with Systemctl. So you've got the one command. So you can go status and say cups. And you can see that the cups service is running. Now, if we wanted to stop it, we could go stop. And I need to do it as sudo. So now if we do the status, so it says that it's inactive, but since 9 seconds ago, because we stopped it, but it's still going to boot up when the system starts. So I'm just going to start the service. And if we wanted to stop it booting up or starting when we go into the different targets, what we could do is sudo systemctl and then disable, I spell it right, cups. And now you can see that it has removed the symbolic links for the multi-user target .once and the cups. So it was part of the multi-user target, and now it will no longer boot up. If I wanted to add it back in, I could type enable. And now you can see that it's put the symbolic links back in so that it will load up on the multi-user target. So the systemctl command is what we would use to basically manage the services completely. Now, if we wanted to change to a different run level, what we can do is systemctl isolate, and then we want to go to multi-user target. So now you can see that I've got this login prompt, and I'm in the multi-user target without the graphical user environment. So to go back to the graphical user environment, I can go systemctl isolate, and I want to go to the graphical target. and it will take me back to the graphical target. So doing the systemctl space isolate and then space the target I want to go to is the same as running tel init on an init based system. Now there's two more commands that I just briefly want to show you in this section. So I'm going to bring up the terminal again. Okay, so the first command that I want to show you is systemd-analyze. And you can see in here that for the kernel it took 389 milliseconds to load. For init.rd it took 2.976 seconds. And the user space took 27.767 seconds. And if we add how long it took for the kernel, the init.rd, and all the user space services to load, it was a total of 31.133 seconds for the entire system to load up, to be able to log in. So that's not too bad, but we can even go further than that. So we can go systemd-analyze space blame, and then we get a list of how long it took each service to load. So we can see that firewall D took 7 seconds, tune D took 6 seconds, and it basically goes down from what took the longest to what took the shortest amount of time to load. Now these services can load up in parallel though, so we don't have to wait for firewall D to finish before tune D starts, and we don't have to wait for that to finish before the modem manager starts, kind of thing. It's not a sequential one after the other. They can load up in parallel because it's an event-based system. So there is a way to say that the network needs to be running before you get a web server start, for example, but it kind of knows that it can go down and load things side by side. It doesn't have to do it sequentially like an init system does, which makes it a lot faster to load up. So that's everything that I wanted to cover in this video, and I will see you in the next one.